Hello gentlemen, this is the last video in chapter 3. We're just going to actually do a couple example problems, a couple word problems, a couple problems on modeling, and then you guys will have a little bit more practice on this, and then we'll move on to chapter 4. But let's get started. We're going to do 2 word problems in this video. The number of bacteria in a culture is modeled by the equation n is equal to 250 e to the kt, exponential growth here, where t is the time in hours. Now I'm given a condition. If n is equal to 280 when t is equal to 10, estimate the time required for the population to double in size. Okay, so we're looking for time for the population to double. So we know our initial population is 250. Who can tell me why? Well, let's see. Initial population is when t is going to be equal to 0. And so when I have this, let's go back here. We're looking at this equation up here. Get my pen. When I'm looking at that equation up here, right there, and I plug in t is equal to 0, I get n is equal to 250 e to the 0 power. And we know e to the 0 power is simply equal to 1. So my initial population is 250. Okay? Now, the next challenge is I have this equation here, but I don't have this value of k. All right, and so what I need to do is use this information right there to find out what the value of k is. So let's plug in what we know. So if 280 is equal to 250 e to the 10k. Now this part right here is now just simply solving an exponential function. Exponential equation. All right, so first step I want to do is to divide both sides by 250. Okay, and I get approximately 1.12 when I do that. Now again, remember the rule. Whenever we had an exponential equation, we isolated the exponential term that has the variable in it. Here we're solving for k. And then I was going to take the ln of both sides. Okay, if I take the ln of both sides, again, I skipped a step here on you. If I take the ln of e to the 10k, I can use my power rule and write that as 10k ln of e, and I know that the ln of e is simply equal to 1. Okay? And I can get a value for ln of 1.12. And then obviously the next step is going to be to divide by 10. And now I have my k value right there. And so my equation for the number of bacteria is going to be 250 e to the 0.0113 t. Okay, so I found this allowed me to find the value of k. Now I want to know how much time it's going to take for the population to double. So to get the population to double, I'm talking about n is equal to 500 because I started out at 250. If I do that, if I plug that 500 in, I'm going to solve the same steps that I did over here, except now I'm looking for t. Okay, so step number 1 is to divide by 250. Obviously I get 2. Again, I want to take the ln of both sides. Again, the ln of this side right here, the ln of e to the 0.0113 t is equal to 0.0113 t ln of e, and again, ln of e is just 1. Okay? And so I can get ln of 2 is simply a number as well. Divide, and I get about 61.34 hours. Okay? There's an exponential growth example right there. Looks sort of like a straight line, but it's actually it's growing pretty quickly here if you look at, this isn't really a straight line. Let me get that stuff out of the way. Okay. If I expanded this out, this would look more like an exponential function, but we've just narrowed down the domain so that we have an idea of what's happening here. Okay? Let's look at another example. After discontinuing all advertising for 2000, the manufacturer noted that sales began to drop according to this model. So here again we have a model, a little more difficult model than we had in the last one, where S represents the number of units sold and T equals 0 represents 2000. Okay, the year 2000. In 2004, the company sold 300,000 units. Estimate the sales in 2008. This is actually called the logistics equation. And so to solve here, we first need to find this k value, right? I need to understand what this k is a constant, but I got to find out the value for it in order for the model, for us to use the model, because I don't have k and I don't have t. Although I'm given t, right? I know what t I want to solve for. If I don't have a k value, then we're in trouble. To do that, we're going to make use of the fact that we have 300,000 units sold in 2004. And so that means that we have the point here, t is equal to 4. Whoops. My pen back here. When t is equal to 4, this is what this line is right here. So t equals 4, s is equal to 300,000. Okay? So I can use that information to solve for k. Now this is not a friendly looking equation. Alright, we're going to have to take our time to solve it. Step number one in solution here is, let's get this term right here and let's bring it to the other side. Okay, let's bring that term right up. And now what I want to do, hopefully you guys realize, I would divide that 300,000, and we're going to do that, and we get 5/3. Alright, this looks a heck of a lot more manageable than we did up there. Let's bring the 1 over, let's subtract 1, and we're just going to get 2/3 on this side. Hopefully you understand that the next step here is going to be divide by 0.6, and I get about 1.111 after I do that. Again, now I'm in a situation where I have an exponential equation. I've isolated the exponential term. I want to take the ln of both sides. Remember, if I take the ln of this side, I'm just going to get 4k. So get 4k is equal to the ln of 1.111. Final step to solve for k is going to be to divide by 4. So now I have my k value. Okay? Haven't answered the question yet, but I have my k value. So my equation now simplifies down to this right here. Now I'm simply want to know, estimate the sales in 2008. Basically all I'm doing now is setting t equal to 8, plugging it in there and solving. Okay? Let's do that. If I do that, I get 287,567 units. Okay? So the challenge on this part, and we actually had to do it in both examples, is we're usually given 2 bits of information. So here's 1 bit of information that we got, and here's the second bit of information. So we had to solve for that other constant. Alright, so these can be a little bit more in-depth problems. Here's some practice. Here are a couple examples that are worthwhile looking on the different models. These are some word problems, gentlemen. Take your time, work through these. Okay, if you have questions, email me. We'll have a help session on them. But I want you guys to work through them. Don't just simply ask me how to do them, because that's not going to help you on problem sets or anything like that. Make sure you practice, you struggle through them, and if you have questions, I can see your work and understand where you went wrong. Okay? Hope you guys have a good day. We have a couple sections in Chapter 4 to cover, and we'll be done for the week. Have a good day.